Okay, let's look at number 2 as a review of how to come up with the atomic weight. So I see in number 2 there are 2 naturally occurring isotopes of boron. One of them is boron 10 and one is boron 11. And 80.1% of all naturally occurring boron is boron 11. So the rest is boron 10. So if I just do 100 minus 80.1, it gives me 19.9%. 19.9% of all boron is boron 10. Okay, so in my head I just want to estimate the average weight. If there's 4 times more boron 11 than boron 10, I know the average is going to be between 10 and 11, and it's going to be significantly closer to the 11. Not 10 and a half, it's going to be more like 10.75, for example, because there's so much more boron 11. Now let's actually calculate the average atomic weight. The first thing I need to do is take the percentages and think about them in their decimal form. 19.9% is 0.199. 80.1% is 0.801. Both of those I'm going to multiply by the data that goes with them. Boron 11 was the 80.1%. And then what I'm going to do with those products is add them together. So I used every piece of data in the problem. I used the percentages, and I used the weight that goes with it, the other percentage that I calculated, that's actually 0.199, and the data that goes with that. And the last thing I just do is add all of those products together. And that gives me the average weight of 10.8. The beautiful thing about an isotope problem is I know this answer already. It is on the periodic table. All I need to do is look at boron on the periodic table and see that indeed 10.8 is the correct answer. So I should never get this wrong because the answer is already given to me. I just have to show how to use the information about the isotopes to get there.